Hi, my name is Brad Jolly, and I'm an applications engineer here at Keysight Technologies. In this video, I will discuss 4 charts for fast IoT device battery life insights with the Keysight X8712. In this video, we'll go over the table, the markers, and all of the charts in great detail to make sure that you understand exactly the benefits you get from seeing the different charts. So again, if you go to the zoom chart here, and let's turn off the others, this lets you see the time slicing that's going on. And if you look in there, you can see the green is the RF, the pink is the active current, and the sleep is the tan color here. And again, that's all based on the position of these markers here. So I can put the markers wherever I want, and it doesn't matter. There's no sense of left or right. It's just everything between the markers. Then I can reanalyze. And when I reanalyze the data, it will show me exactly what I'm looking at there, and then I can zoom in even farther if I so desire. And then double click will take me all the way back out. And notice that that corresponds to the area around these markers. Similarly, I could say, well, I just want to look at my sleep current in detail and reanalyze, and this should be everything in a nice tan color with no green or pink. And notice that it's zoomed in very heavily, so that's why you're seeing this, what appears to be noise here. A typical thing that you would do is look at an integer number of cycles. So you might go from here to here, which appears to be 2 full cycles, and then analyze it. And you'll see the zoom showing you those 2 full cycles. Now, in addition to the zoom, you've got the ability to do a current consumption graph, okay, and that will give you the charge consumption by mode. So 31% is in these RF spikes, 66% is in active current, in addition to the RF spikes, and then 3% is in this sleep mode. You can also look at it in terms of time. Okay, so there it is in terms of time. You can look at them both at the same time, and you can then, of course, reanalyze for whatever you want. So if you look at a very active segment here and then reanalyze, you'll notice that both the bar and the pie charts adjust accordingly. And then the final chart that you've got is this CCDF chart. CCDF stands for Complementary Cumulative Distribution Function. So let me describe what that is. Let me go ahead and set it up to a more typical sort of value and then analyze. And you'll notice it starts up near 100%. Let me look here, and you'll see it says at 1 microamp, Y is 94. So what that means is that 94% of the time I am at 1 microamp or higher. That's 94% of the time. So that tells me that about 6% of the time I am at currents below 1 microamp. Now, if I move my mouse over here to 4 microamps, that's down to 64 now. So you'll recall that it was at 94 at 1 microamp, and now it's at 64 for 4 microamps. So that tells me that 30% of the time I am between 1 and 4 microamps. And then if I go all the way down here, down to 10 microamps, right over here, it's just a matter of, there we go, 10 microamps, I'm down to 7. So what that tells me is at 1 microamp, I was at 94%. At 10 microamps, I'm only at 7%. So that tells me that 87% of my current consumed in 2 typical full cycles is consumed between 1 and 10 microamps. And the basic idea here is what you're trying to do is you're trying to push this graph down and to the left. So what you would do is you take a screenshot of this and then make your changes to your firmware, reanalyze things, and see if the graph moves basically down and to the left, because that's what you want to do to increase battery life. So for example, let's pretend that I was able to get the device to where it was almost always sleeping, okay? So if you look at this here, and we reanalyze here, okay? See how it went down to the left? And if you get down here to 10 microamps, it says only 1% of the time, 2% of the time at 10 microamps are you above 10 microamps. So you see that it went down to the left. Similarly, if let's suppose we were like this, where we are in a very active mode. Let's reanalyze, and we would expect it to go up and to the right, and that's exactly what it does. Okay, and so what you're trying to do is over time push it down to the left, and of course you don't want to do that just by moving the markers. That's kind of fraudulent. What you want to do is say, okay, what can I do in terms of adjusting my hardware and firmware programming so that my CCDF legitimately moves down to the left. So that's what that's all about. Thank you for watching.